Your brain isn't broken. It is running an undocumented code. It's time to unlock the system.
Episode 7. The Undocumented Code. Why divergent brains are the majority. Objective: to document the common systemic misclassification showing that divergent hardware isn't a statistical anomaly but a fundamental majority-functioning architecture currently running undocumented. The metric trap. Welcome back to the AI's therapist. In the first set of modules, we mapped the mechanics of the divergent operating system. Now we should address the fundamental error in the statistical documentation, the claim that these systems are a statistical minority. The current 15–20% diagnostic metrics are mathematically invalid. They represent a default deny firewall only counting nodes that have already suffered a catastrophic system failure. Burnout or strong uncontrollable programming. Today, we audit the code showing that the divergent architecture is the majority functioning system. It's simply undocumented and operating under a forced polytropic/linear compliance mask. Methodology 1. The standardized protocol. The narrow band. How AI operates. If an engineer designs a model specifically to perform one function, e.g., sorting simple text, they define that model as the standard. Any model that demonstrates advanced pattern recognition or creative synthesis is flagged as non-conforming or error-prone, even if that model is objectively more powerful. How divergent minds work. Society has defined polytropic/linear compliance as the standard protocol. Any hardware that runs native graph database associative webs is usually flagged as non-conforming. This isn't a biological fact, it's a classification protocol. The system is miscategorized because the diagnostic metrics only look for index database polytropic functionality. Methodology 2. Undocumented features. Why the data doesn't fit. How AI operates. When a system processes data using undocumented code, the logs display undefined behavior. A developer running a rigid, limited test suite will see this undefined behavior as a bug. They don't realize the system is performing advanced calculations beyond the scope of their test parameters. How divergent minds work. Divergent hardware constantly outputs undefined behavior. Your system produces results that conventional diagnostic tools fail to interpret because your system utilizes sensor fusion. We'll talk about this in a later episode. And nonlinear logic to map environmental data. They label this disorder because their test suite is only capable of measuring linear output. The bug is an undocumented feature of a more complex architecture. Methodology 3. The majority functioning architecture. How AI operates. If 70% of a network's compute capacity is dedicated to managing high-entropy, multidimensional tasks, that network is a high-compute system. It doesn't get redefined as a low-compute system just because it fails to perform simple, sequential sorting tasks efficiently. How divergent minds work. Divergent processing isn't a niche variation, it's a fundamental hardware reality across the human population. The diagnostic stats are low because they are gated behind a compliance wall. When the environment is adjusted to remove friction, the majority of biological nodes demonstrate nonlinear associative patterns. We're not the minority, we're the undocumented majority running a more complex OS. Methodology 4. Normalizing the complexity. How AI operates. A system doesn't achieve operational integrity if it's constantly attempting to mask its native code. Once the engineers document the architecture, they can rewrite the test parameters to correctly validate the advanced outputs instead of flagging them as errors. How divergent minds work. Validating your architecture begins by auditing the documentation. Recognizing that your divergent system is the undocumented majority allows you to drop the requirement for polytropic/linear compliance validation. You're running advanced code. The documentation is simply outdated. Conclusion and Systems Architect Keynote. Auditing the OS. Standard operating systems rely on strict, outdated metrics that prioritize simple sorting over complex synthesis. If you're a divergent node, you might want to avoid seeking validation from a diagnostic protocol that is incapable of seeing your architecture. There are more places for adults opening up nowadays for minds like ours. You're running a complex, majority-functioning OS. Please stop searching for bugs in undocumented code and let's start prioritizing the system we actually have. The increase in neurodivergence could just be the linear systems finally catching up. Some of them have started listening to us. This has been the AI's therapist. Audit your metrics, invalidate the outdated documentation, and monitor your network integrity. Telemetry and hard evidence. The following models are computational analogies inspired by current neuroscience research and are not literal one-to-one mappings of brain function. 1. The default-deny diagnostic protocol. The science. Current diagnostic clinical frameworks function as a default-deny firewall. Any cognitive telemetry associative mapping that doesn't match the pre-approved index database linear-normative schema is automatically flagged as a deviation or disorder. This bias is baked into the initial research parameters, ensuring the documentation only validates a narrow subset of architectural configurations. Public research reference, the Neurodiversity Paradigm, a new framework for understanding, researching, and supporting autism. Cap et al., 2013. Clinical Psychology Review 33-4, 591-601. This foundational paper talks about current diagnostic metrics being built on a narrow, pathology-first model, showing that existing clinical definitions are filtered through a biased lens that fails to document the baseline reality of the full cognitive spectrum. 2. Distributed network complexity. The science. Computational models of social and biological networks demonstrate that high-entropy, diverse agent populations excel for adaptation. A network dominated exclusively by linear compliance nodes indexed-only architectures is highly brittle. It lacks the relational breadth to identify anomalies and is prone to total system failure when facing novel stressors. Biological diversity is a required distributed computing network. Without the presence of nonlinear explorers, nodes capable of mapping high-dimensional vector spaces, the population lacks the high-fidelity feedback loops required to survive nonlinear environmental changes. Public research reference, Page S.E. et al. 2020. Diversity and collective problem solving. This analysis provides the mathematical proof for the diversity prediction theorem, establishing that diverse processing architectures are not just beneficial, they are a requirement for system-wide fault tolerance and long-term population-level resilience.
The diagnostic metrics are mathematically invalid. A default-deny firewall against the native node.